Hi, and welcome back to Programmable Logic Controllers, Module 2. I'm your instructor, Steve Grotta. Thank you for sticking with this program. And if you like it, please hit the like button and subscribe to the channel so I can bring more content. So let's get started with Chapter 5. Module 2 and Chapter 5, Input. Sync or source. And we're going to go over this in a couple of different ways because this is probably the single most confusing but most important subject matter in a PLC to get your basic understanding and your foundation correct. So you have an input and you can do syncing or sourcing, okay? And they can be defined as positive and negative logic. For the purpose of this discussion, I will define sourcing and syncing in relation to voltage, not current. Please note that manufacturer definitions vary, as some define by current flow. And what that means, you'll see in the next couple of slides. I'm going to try and explain all of that. Voltage sourcing, or positive logic, is when the input module requires a voltage, 5, 10, 12, 24 volts DC, be provided to the input terminal to make the input go, quote, on. The common of the input module is wired to the common of the power supply, or 0 volts DC. In theory, this is a syncing input in regards to current flow, because current flows opposite of the voltage. Voltage syncing, or negative logic, is when the input module requires a voltage 5, 10, 12, 24 again, volts DC be switched to common, or to 0 volts, from the input terminal to make the input go on. The common of the input module is wired to the voltage source of the power supply, whatever voltage DC. In theory, this is a sourcing input in regards to current flow. Now that can be confusing, but hopefully over the next slide or two, you'll understand it. The term PNP, or positive type, sources a voltage, and NPN, negative type, sinks a voltage, and they're interchangeable here. So here you see a diagram of a common PLC. This one happens to be from Automation Direct, and it is showing you a module that's capable of doing both syncing and sourcing, depending on which voltage connection you connect to your common of the input module. And common is a relative term, okay? There are common to all of the push buttons, and then there's a common on the input module, which is common to all of the inputs. So if you look at this at the top, there is a section that shows you a syncing field device and a sourcing field device. This is what we're talking about when I'm describing sourcing and syncing, is the field device and what you're bringing to the input module. Internally, the module, based on what common you connect, can be NPN or PNP, or syncing or sourcing. But it is the opposite of what you're bringing in as far as voltage goes. So as you can see, a sourcing field device has a power supply shown, with the positive of the power supply is connected to all of the push buttons. That's considered a common to the push buttons. The negative of the power supply is connected to C1, C2, C3, and C4, because each of the segments of inputs could be wired differently. The common is connected to the 0 volts, so therefore this is a module that's requiring a sourced voltage, a switched 20 plus voltage into the input to make the input go on. On the left-hand side, you see a syncing field device, and you would see that everything is the polar opposite. where the positive is connected to C1, C2, C3, and C4 of the power supply. The negative is common to all the push buttons, and those push buttons, when pressed, would sync the voltage coming out of each input down to 0 volts. Here is another diagram showing the exact same connections, except the nomenclature is different from the manufacturer. So it's talking about on the input side, not the output. On the input of the device, it's describing the type of input it is in the device itself, not the field device. So here they are side by side, and you can see that the differences in the two connections and the nomenclature involved. So you see when the positive is connected to the commons of all the push buttons coming in and then bringing positive into the input, it's actually called a syncing input on the component side, but it's a sourcing field device. And the opposite of a sourcing with a sourcing input is the positive on the internal devices plus voltage, and we're looking to sync that voltage down to 0 volts with a syncing field device. But that's actually called a sourcing input because the current flows in the opposite direction. So here we're going to try and diagram for you what a syncing and sourcing looks like. So here I'm putting in a common. This is the common for the inputs. This would be a connection on your common of your module. This is your incoming power or your common connection for your field device. I'm going to insert a normally open push button. Let's see. There we go. And we'll align it a little bit here. There we go. And now I'm going to put a normally closed push button for input 2. I'll make the connections to the inputs themselves from that field device. There we go. So that connection and that connection are actually connecting your push button right to your input. And now let's put in a couple of descriptions. So in a case of here we're going to start with a 0 volts on our common, plus 24 distributed to our push buttons. So each input will receive 24 volts when we push the button or lose the 24 volts on the normally closed. So that's going to be going all the time. This would be considered a sourcing circuit. So now if we flip-flop that and I change this around and I take the 24 and I connect it to the common in the module, input module, and I connect my field devices to 0 volts, then this would be a syncing circuit or NPN. Hopefully that is pretty clear. This gives you the basics for what you're doing in your machines. Without this basic understanding, you're going to have a hard time connecting up circuits in the proper manner. for Chapter 5. I hope you enjoyed this little video on syncing and sourcing. Again, if you like it, please hit the like button and subscribe to the channel. Thanks.